Hello, and welcome to the TEALS School Information Session for schools interested in applying for partnership for the 2016-17 school year. My name is Patrick Osteen. I am a regional manager for TEALS in the Pacific Northwest area. A little bit about my background. I am a former high school physics and engineering teacher in the DC public school system. I was also a science department head and a FIRST robotics coach and mentor. What I'm going to do is walk you through what a partnership with TEALS looks like and provide you with a lot of the essential details that are critical to know before starting an application. Before getting into the details of partnership, let's look over some statistics that show the current state of computer science education in the US and show why access to computer science education is so very important for your students. So this graph shows what's referred to as the job-student gap. There's a rapidly growing tech sector in the US economy, somewhere on the order of 1.4 million programming jobs expected by the year 2020. At the same time, the not so rapid growth of computer science graduates. And what we see here is a huge disconnect, or a gap, of about 1 million unfilled programming jobs expected by the year 2020. So there's a huge need here, and it begs the question, what are schools doing to meet that need? Currently, not enough. The numbers we just saw indicate that we're not seeing nearly enough computer science graduates out of college. Well, so let's take a step back and see where things stand right before college at the high school level. This graph shows the number of AP exams taken by subject last school year. And let's see where computer science falls in the spectrum. Way down here. It raises the question, why are so few students taking AP computer science? Is it lack of interest, or is it lack of exposure? We would argue the latter. Given its importance in the economy and the importance of developing computational thinking skills, it really belongs with subjects like physics and biology and economics. But students just aren't getting that same kind of exposure and access to computer science education. It's important to take a minute to note here that this isn't just about getting more computer science majors to fill all those jobs. Being digitally and technologically literate is increasingly important today. We need to have informed citizens in order to have a healthy democracy. With the growth of surveillance and privacy concerns, big data, artificial intelligence, digital crime and currency, and more, there's so much for our students to learn about today. Also, students, by taking computer science, develop their computational and critical thinking skills. And that will help them in a lot of other areas, including all STEM fields, healthcare, retail, and more. So we've looked at some national statistics. Let's see how things stand at the state level. Here in Washington, which is where TEALS is based and was started in 2009, we have a thriving tech industry. We've got Microsoft, Amazon, Boeing, Google, and more. One would think in a state like this that you would have greater participation in computer science education, but not really the case. We see last year 2.1% of AP exams given in Washington were AP computer science. Very small percentage. Now that is up from 1.3% last year, so positive strides have been made, but still not nearly enough. And especially troubling are the statistics around the participation of minority students and females. Only 39 African American students took the APCS exam in Washington last year, only 70 Hispanic students. The female representation better than the national average, but still not close to what it should be. Okay, well, let's take a look down south and see if our tech hub neighbor California is doing any better. Well, in fact, when you look at the numbers, they're doing worse. 1.2% of AP exams given last year were computer science. And just 242 high schools out of an almost 2,700 public and private schools in the state actually offered AP computer science. In terms of underrepresented minorities, you see a pretty similar picture as to what we saw in Washington, clearly not representative of the state's population. Okay, so let's build a more complete national picture by looking at some additional states, starting with DC public high schools, which is where I used to teach. So in the DC public and charter school system, there are approximately 20,000 high school students. Of those 20,000, only 46 took the AP Computer Science exam last year. It is a shockingly low number. Now on the plus side, there is better minority representation in the APCS exam in DC, but clearly much work to be done there. Looking at additional states, Ohio, Massachusetts, New York, you can see that we're building a very similar picture throughout the nation. Low participation in the AP Computer Science exam, and female and underrepresented minorities just not representative of the state populations or the national population. So the question that arises out of all this data I've been presenting is, where are all of the computer science teachers to teach our high school students? Well, if you imagine just graduating with a computer science degree, and you know out there is this huge industry demand for electrical engineering and computer science majors. Also keeping in mind that the vast majority of states do not have a clear pathway to teaching computer science or certifying teachers to teach computer science. You don't see high schools at your recruiting fairs, and you're thinking about that big financial sacrifice of choosing to teach versus going into software engineering. So if you imagine a school that has no computer science teachers, it thus has no computer science courses to put in its course catalog, and then there's no students to sign up because the course doesn't exist. So as a result, we have no perceived demand in that school for computer science until somebody speaks up about it. So this is where TEALS comes in. TEALS partners with schools that are committed to offering computer science classes, but they just can't find the teachers with the necessary CS background. Together as a partnership, we in schools build and establish a sustainable CS program through the support of tech industry volunteers. We place a volunteer teaching team with a classroom teacher that's committed to learning the computer science content, so that over the course of 2 years, that teacher goes through a progression and is eventually able to reach the point that we call handoff, where they're able to independently teach the course. We ask schools to schedule our computer science classes first period. That way our volunteers can come in the morning, support the teacher in whatever way they need to, and then go on to their regular day jobs. For this volunteer support model to work, we need full school administration and teacher buy-in and support. And we'll go into more detail about that in future slides here. The 2 courses that we partner with schools to offer can be seen below here. We've already talked briefly about AP Computer Science A, which is a year-long college-level course that's taught in Java. I'll talk about that in more detail later. We also partner with schools to offer Intro to Computer Science, which is a semester-long course that's meant to be more of a broad introduction. For the TEALS teacher support and development model to be successful, we very much rely on committed and passionate volunteers. They give up almost 300 hours of their time over the course of a school year. We ask them to do summer training to be prepared for the classroom, both in-person and online training. They add to their commute. There's of course time planning for lessons and grading and the actual time spent teaching in the classroom. And then we have regular meetups and team meetings that take time as well. So let's take a look at the landscape in terms of who TEALS partners with. Whether it's public, charter, private, religious, independent, you name it. In terms of location, whether it's high performing or high needs, TEALS is there. We have a lot of experience working with just about any kind of school, and if it's a school that wants to have a computer science program, we are certainly there to support them. In terms of the diversity of TEALS students relative to the national industry averages, we see 29% female students in TEALS classes, and 20% of students are underrepresented minorities. Both of those a good bit higher than the national average. In terms of aspirations, 93% of TEALS students do see themselves as college bound, and 70% say that this is their first computer science class they've ever taken. In terms of extracurriculars, you see that TEALS students have a wide range of interests and participate in a variety of activities. So So our program doesn't only help teachers and schools build a sustainable computer science program. It also just helps to build excitement for computer science and being a part of the CS community. So through that industry connection of our volunteers, there's college and career talks, there's field trips, potential internships. And the TEALS program also provides class t-shirts and raffle kits with prizes to give away to build excitement in the classroom. So let's look at some of the backstory and the history of TEALS and how it got started. It all started with just one person. Microsoft employee Kevin Wang decided that he wanted to teach high school computer science, but he also wanted to keep his regular job. So he worked it out with a local school that he could go in the morning, teach first period computer science, and then go on to work at Microsoft. Well, a few other schools in the area caught wind of what he was doing, so Kevin recruited some of his friends, and by the next school year there were 4 schools participating in this concept. And then over time, Microsoft started to catch what Kevin and his friends were doing, and they started putting some dollars behind this movement, and through that we saw the growth of the program up to where we are today, where we're partnering with 162 different schools in 17 states in the District of Columbia, and over 6,000 students have been impacted by our program this year. Just to get a different perspective, looking at the map here, you see where it all got started in Washington State. Definitely a number of schools in that area, but we have been expanding throughout the U.S. and look forward to partnering with more schools regardless of location. Now we're going to look at the 3 different support models that we offer schools, depending on the background of the teacher and the level of support that they need. The TEALS co-teaching model is our primary support model that we use, and it's meant for teachers that have little to no background in computer science. For this model, we have a teaching team that can be thought of in 2 parts. On the left, you have your volunteers, and on the right, the classroom teacher. Typically, we have a volunteer team of 4, and they team teach with that classroom teacher, at first taking on the majority of responsibilities, instruction, and generally leading the class. And over time, those responsibilities pass from the volunteers to the classroom teacher as their confidence in the content develops. The team splits in half, and each half of the team teaches about twice a week. Because the class is scheduled first period, typically they're done by about 9:15 in the morning so that they can go on to their regular jobs. We do require schools to set aside a stipend of $5,000 per course per year, and that money is divided equally between the team of volunteers. This stipend is meant to cover any costs the volunteers incur from adding to their commute, the background check fees, and just generally meant to be a token of appreciation from the school to the volunteers for all the hours that they put in over the course of a school year. The volunteer team is broken into 2 roles, one role being the teacher, and the other role being the teaching assistant, or TA. The teacher is responsible for the majority of lesson planning, planning out the whole course, instruction, and grading, whereas the teaching assistant is more of a lab assistant, offering that one-on-one help to students during lab work and assisting with grading. So moving over to the classroom teacher side here, for our model to work, there must be a committed and excited teacher that really wants to learn to teach computer science. They must also be committed to working with and building a lasting and meaningful relationship with their volunteer team. And we do require that they have at least 2 years of classroom experience. They're also committed to that handoff concept, that they'll be able to teach the class independently after 2 years. We do require summer professional development, either in person or online. There's a number of options listed in our implementation guide for teachers to look at. We also ask schools to give sufficient prep time during the school year so that the teacher can really master the content. We ask teachers to fully participate in the TEALS community, both in person and online, and support TEALS classroom activities such as the Hour of Code, t-shirts, field trips, and so on. Lastly, for teachers that are going to teach the AP Computer Science A course, we prefer to find teachers that have experience with STEM subjects in the AP world, such as AP Physics, AP Biology, or AP Calculus. TEALS does offer two other support models that are more appropriate for teachers that have an existing computer science background or have already been through the TEALS co-teaching model for 2 years. Starting here with the teaching assistance model. In this case, the classroom teacher is able to independently teach the course, but they still want that additional support on a day-to-day basis, having a volunteer in the classroom. It helps with grading, lowering the student-teacher ratio, and it keeps that industry connection for the students daily throughout the school year. The third option is our consulting support model. And again, this is where the classroom teacher is able to independently teach the course, but they don't need that everyday support of having a volunteer in a classroom. They still want to be a part of the TEALS community, which involves curriculum support, monthly meetups and discussion groups, being on the online community, and retaining an industry mentor that occasionally comes in for guest lectures or career talks. And they're also there for the teacher for online and phone support. Now that we've seen the details of the 3 different support models that TEALS offers, let's look at this graphical summary because it can really help us to see the big picture. On the left here, we've got the various responsibilities associated with running a successful computer science class. Starting with classroom management, you can see that the expectation of our program is that from the beginning of partnership, the teacher is leading classroom management, taking attendance, keeping students on task, managing behavior, and so on. However, in the other categories, it's clear to see that the expectation is that our volunteers are taking on the majority or all of those remaining responsibilities. But over time, those responsibilities are handed off to the teacher, to the point that eventually the teacher in the consulting support model is using volunteer support very minimally or none at all on a day-to-day basis. Recruiting and retaining engaged and committed volunteers is really essential to the successful partnership that we have with schools. And we do expect our partner schools to engage in this process alongside us. By sending out emails, newsletters, posting on local blogs, and generally reaching out into the local community and to civic leaders, that helps to get volunteers that are truly locally connected to the school and thus even more invested in the success of the CS program there. TEALS also engages at talks at local companies and organizations and works with national partners to do recruiting from our side. But the key is the best volunteers have that local connection and have a lasting relationship with the school. Now we're going to take a deeper dive into the different computer science courses that TEALS partners with schools to offer, starting with Introduction to Computer Science. We base our curriculum on UC Berkeley's CS10 course, which is a computer science course for non-majors, and we've adapted it for high school and made it 1 semester long. It's meant to be run once in the fall, once in the spring. It is a survey course comparable to, say, a conceptual or non-AP physics class, and it's a broad introduction to computing principles and teaching students how to turn their ideas into code using a block-based drag-and-drop programming language seen here called Snap. It's a way to visually engage and excite students of all grade levels in computing principles, assuming completion of geometry. The required textbook for this course is called Blown to Bits, and details about that can be found in our implementation guide. The next course we offer is AP Computer Science A. Our curriculum here is based on the University of Washington's Intro Programming course. So this is a college level class that's taught over the course of the whole year, with the culminating AP exam in May. Now, this is a very challenging and thus very rewarding AP class that is comparable in difficulty to Calculus BC. The course is taught in the Java programming language, which is very much an industry standard and used throughout the tech industry. And typically we see anything from sophomores to seniors taking this class as long as they have that Algebra 2 prerequisite. The required textbook for this course is called Building Java Programs. The College Board is launching a new AP Computer Science course for the 2016-17 school year called AP Computer Science Principles, or APCSP. This course is not meant to replace the existing AP Computer Science A class, but rather to complement it by teaching a more broad range of foundational computing concepts, to broaden participation in the study of computer science. TEALS is currently evaluating curricula and does plan to pilot this course with a small cohort of schools. So if you are interested in this, I encourage you to go to the College Board website to learn more and also indicate interest on our application. In some cases, the schools that we partner with are located in areas where there's little to no pool of tech industry volunteers. Often, this is in rural areas. In this case, we bring in a distance learning model. So using teleconferencing technology such as Skype, volunteers are able to remotely instruct and assist students as well as the classroom teacher. Of course, there are some additional requirements and logistics that come into play here, so please read the equipment requirements in the implementation guide if this is more appropriate for your school. For your school to have a successful partnership with TEALS, there are a number of school responsibilities that are really important to note before starting an application. The first thing your school needs to do is designate a partnership coordinator. Typically, this is an administrator, such as a principal or assistant principal, that will serve as the main contact between TEALS and the school. They'll be responsible for classroom observations and giving feedback to the classroom teacher as well as the volunteers. They'll also be responsible for just generally ensuring that all of the details of our partnership listed here and in the implementation guide are taken care of in the appropriate time frame. That includes class materials and equipment, making sure there's one textbook and one computer for every student, with some extras just in case. The volunteers need their background checks, network access, parking, and ID cards taken care of well in advance of the start of the school year so that they can successfully enter the classroom on day one. The partnership coordinator needs to work with counseling department to get that first period locked down for computer science. The volunteer stipend and reimbursements need to be planned for and paid out. TEALS will help to facilitate a back-to-school meeting in August to make sure that all pieces are together for a successful school year. And some general things to note: embracing and supporting your volunteers is so essential because they're the most important resource that our program can offer. Facilitating and encouraging course handoff so that that teacher is able to individually, independently teach the course over time is essential to building a sustainable computer science program in your school. And lastly, the school needs to grow the CS program, expanding course offerings and extracurricular opportunities. Okay, so what is next? You've now watched the school information session, and now it's time to read our implementation guide as well as our partnership agreement. Once that's done, you're ready to head to our web address here, tealsk12.org/schools, and fill out an online application. Applications are going to be reviewed on a rolling basis between late November and mid-February. And once your application is submitted, a TEALS regional manager will set up an interview to finalize a potential partnership. In the meantime, please do reach out to your local community and tell them about TEALS and your interest in growing computer science education. Connect with local organizations and companies in order to help us get committed volunteers into your school. Thank you very much for listening, and we look forward to seeing your application.